possibly stand up, some of you that I may have missed? Mr. Dolan. Liz Dolan. Glad to have you here, sir. Yes, sir. Cliff Harrison. Yes. Cliff Harrison. Cliff Harrison. Great to see you. Do we have anyone else? I think we've got it. Good. Well, the reason I wanted to introduce Mr. Paradiso to you is because what a labor of love. He has put together a museum quality model. The first helicopter here in the United States anyway, to fly. Am I correct in saying that? I mean, I can't say that about Europe. I can say that about the United States. But we're very honored to accept this remarkable gift. And I'd like to ask perhaps that our president, Tom Snyder of NASA, step forward. And I'd like to ask Mr. Paradiso to make a comment or two, and perhaps Mr. Snyder to respond. Thank you.
Good afternoon. To begin with, it made it sound like Mr. Sikorsky and I were the only ones in the company when I joined him in April of 1941. Actually, there were about a dozen engineers at that time. In 1943, I was among a handful of Sikorsky engineers who called a meeting, and the topic was trying to start a professional society, which turned into the American Helicopter Society. In 1984, at the 40th anniversary of the society, I gave the society my draft copy of the Constitution. And so when I received word of the present meetings, term date, I started to think I'd like to do some more for them. And so what I did is I engaged the services of 3 master model builders. And I had taken about 50 pictures of the Sikorsky helicopter when it was in the foyer of the hotel at the 40th anniversary. The Sikorsky company provided me with engineering drawings and many photographs during the restoration during 1984. So the 3 model makers made this museum quality model. By museum quality, I mean it's a 1/20th scale. All the components in it are exactly as it was in the original helicopter. This is as it looked when it was flown from the Sikorsky plant in Connecticut to the Henry Ford Museum in Dearborn, Michigan. It has little patches and so forth, the age effect on the skin. It's what we call preserved rather than restored condition. And the details include such things as the wires, the magnetos, the oil lines, all the control cables, the mechanisms, all the components, the structure, and the rotor details, right down to the nuts and bolts. So it was a great pride that I give this model to the American Helicopter Society.
Tony, I'd just like to thank you very much on behalf of the society and especially the founders here today. This is a beautiful model. The detail is just amazing. And I think it's a wonderful representation for 450. So thank you very much.
Mr. Myerson, weren't you the chairman of our first publications committee back in 1943?
That's correct.
All right. Now I remember.
Let me add a footnote to that. You know,
Yes, sir.
they're recently trying to change the name of the society, from the American Society, to something else. The first publication had 2 articles in it, both by Britishers, one by J.A.J. Bennett and the other by Archie Gray. So we shouldn't get too tight to this American name. I mean, to this being the American Society being not covering the whole world. It does. I notice you have Japanese here and everyone else. And I hope you'll say that.
I'm sure we will for the foreseeable future. What I would like to do is introduce perhaps our moderator here this morning, and I'll allow
going to make is got only 585 slides, so I'm going to be a little rapid in my presentation of them. That one that you just saw, the PV2, I don't think I had anything to do with it. You have some view graphs there, like this one. That's a view graph. That's not my slide. Okay. Now that
was intended to introduce you, to let people know that you were really there.
thank you. That's very good. Appreciate it. And if they have trouble, God help them. I was going to talk about the people in that picture, but I'm sure you had them all identified. The presentation I'm going to make is, I had to search my background of presentations and slides and many hundreds and hundreds of slides, and I picked this one as being the most representative that would be interesting, and that takes me back to the multiple past. From about 1958, 1959, I had a lot of contact with the Russian helicopter industry, the USSR industry. And at that time, there was a lot of dissension in the ranks that said, what are you so friendly with them for? I'd go down to Washington and the State Department would say, are you giving away any secrets for the information you're bringing back? And the biggest concern was, what am I giving away and how much am I getting back? But it finally, after many years, all wound down to where everybody's pretty friendly in this world. At least it seems that way. So with the slides, I'm going to go through a lot of them very fast, but it's going to give you an idea of how we progressed in the industry. First at Sikorsky, we had the VS-300, and then we progressed to an Army machine, which was the result of the remaining money in the Army Helicopter Fund, which was financed by Congress. And I'll just go back just a very bit. He's only got 2 people on there, should be 3. I don't know what happened there. There it is. I just thought I'd put that in there to bring the old-timers back into the 50th anniversary. The fellow on the right, on my right, is Mihail Mill, and I knew him quite well. And I'm sorry, that's Kamov. And Mill is on the left. And he's tall. Well, Mill was only about 5'5", and he wouldn't let pictures be taken at his facility outside of Moscow until he got into a 2-step stoop to get into the office, and he stood on the top one. He said, I build bigger helicopters than you, I must stand taller, which he did. And Kamov didn't say very much because he was not very important in those days. Coax was anathema. Mill didn't believe in it, and he was sort of the most powerful of the helicopter designers and builders. And Kamov sort of took back seat as second place. Continuing on with the slides, have I got the, oh, I've got the thing, yeah, sorry. I didn't see her put it down. Then, when we go to helicopters, we find that between the Russian and the U.S., the helicopters were about the same size, about the same power plants, only the power plants had different names. On ours, and a ship this size, the S-51, we had an R-1340 or an R-985, and in this aircraft you have the Russian equivalent. I used to know the names in Russian, but I can't remember them now. And they only painted this red because we were going out of the country on a World Helicopter Championship, so they painted the helicopters red. The diameter of the rotor and the rotor system, the transmissions and all, were displayed in a museum at the Mill facility, and they were pretty much the same as U.S., nothing important, nothing different. And the blades were steel spar and ribs and fabric. And then you went to about the same helicopter you'll see in a minute, We went to the U.S. helicopters, the ones that we delivered first to the Army and started the helicopter trend in the U.S. That's an R4, actually a YR4 with the same type spars, same type blades. And at that time we were developing for the Army a military combat machine. As you can see, we're dropping bombs. They weigh about 6 pounds each. And we're lucky we didn't have to carry anything heavier. The engine we had was the Morna Scarab 180 horsepower, and it did well picking the aircraft up. It wasn't too hot, and there was only one person in it. But we had the contract was for a two-person machine, observation machine, 180 horsepower, 60 miles an hour for cruising speed, didn't say maximum speed, 100 miles of range, and that was the spec for the machine. We got $50,000 to build this. We had to design it, build it, deliver it, and test it in the field. $50,000. You say, why? Well, United gave us $50,000, United, at that time, United Aircraft, because the Army didn't have any more money, and they liked Mr. Sikorsky, and they said, we got to honor him, and we will donate that $50,000 to the Army, though it hurt them very much to do that. Then you got the R5, which was the next machine that we got a contract for. It's a two-place observation machine with a 450 Pratt Whitney engine, and tandem cockpit, which was dictated by the Army Engineer Corps, who seemed to be the ones interested. And that machine survived quite a lot of development and change, and it had a 48-foot diameter rotor, again steel tube spars, and pretty standard transmission, epicyclic going up through the engine, which was flat underneath the rotor. And that aircraft saw a lot of service. It had a very high top speed of 102 miles an hour. It did very well. Then we came to the R6, and I sold the R6 to the Army right about the time we were building a second production lot of the R4, the square fuselage, previous slide you saw. This one was something that I was so enthused about helicopters that I thought we could jump 20 leagues quickly. And while we jumped 20 leagues, we didn't jump too far because this came in under a combat aircraft procurement, and General Hap Arnold gave us a contract for 900 after we demonstrated the aircraft in Washington. It had cellulose composite cowlings. They're composite, but cellulose, that's paper. And they worked pretty well, though they were very brittle. And we had eight sets of cowlings per aircraft. The cowlings for one set, 15 cowlings was $100. That was what we charged the Army. The tail cone was magnesium, 20 thousandths magnesium formed, and I got magnesium into the industry because I thought that would be a big advancement. Very light metal, third lighter than aluminum, and it was not too resistant to corrosion. If you get it out in salt air or water, well, you might have it disappear while you're flying. At least that's what the pilots thought, but it didn't happen. And the pylon was 1/8 inch aluminum sheet, no steel tube structure. The landing gear was a rolled aluminum sheet into a cone, and that weighed about 11 pounds, and for a 2,600 pound aircraft, it operated very well. Cabin was fiberglass, and that was a very unusual thing. Now this, remind you, is 1943, and that's a hell of a long ways to go, and I think we're still struggling into the composite industry to decide what things should be made of composite or not. The nose we made into an open form and sucked it into it, and whatever shape it came to, that was the nose. It looked pretty good. It was eighth inch thick, and everybody said it's too thin, it'll break. We finally found that if you stretch a smaller sheet, you got stretch flex, and stretch flex, you could drive a Jeep into it, and the plexiglass nose would stretch and deflect, but it wouldn't break. And that developed stretch flex. We didn't know what we had, and Rom and Haas got the patents and made all the money. So there were a few times when we could have made money, we didn't know what we were doing. Going parallel again, the Russians had the mill too, and they built it. They felt nobody wanted it in Russia, so they gave it to the Polish to build in production. And they've been building it ever since. And you might hear a little bit from Frank Vasecki, because a model or a version of this, the Falcon, is certificated now in this country, built in Russia, built in Poland, and it could be a continuance of this model. Then I've got these slides not in any real sequence and size and date, but this is the CH-54, the S-64, and it was built from the sometimes I forget the things, but anyway, it was built from an early Army machine that had sponsons on it, and the two R-2800 engines. And when we built the machine with a 68-foot rotor, it got so overweight that we had to run the engine RPM on these R-2800s to 2,800 RPM. And we had engines that lasted sometimes 10 hours. And the basic thing was they'd run out of oil. You'd burn the bearings up, you'd just grind them out, and then you'd have to replace engines. And the Army was pretty unhappy, but we finally made it into a crane, put in the JFTD-12 turbines, Pratt & Whitney turbines of 4,000 horse each. And this became a very substantial machine in the Army, in the National Guard, just recently retired. This was an Army's version of making the machine very useful. You put 4 155 howitzers, one on each quadrant, and you could fire any quadrant and just spin the engine machine around. No matter where you turn it from. And now they said, where do you put the people, the crews for the cannon? As we put them at low depth, and we actually flew this in demonstrations. And some of the higher level brass were criticized the Army group that did this because they said it's too dangerous and all. They said, well, sir, we don't have to have a cabin, we don't have to have protection. He says, anybody gets shot, we dump them overboard out of the net. And it's a pretty damn good deal, but it never got useful in the Army. This is just a step. Then getting back to the Russians comparatively, this is a Mil-8, and that was a 18,000 pound machine and grew to 20, and it had a Wright Cyclone R1820 engine, but a Russian version, and the Russian version was 400 horsepower more, and when I went over there and flew on it, why, I thought they copied it, and when they told me the dates and all, I realized it was about the same date of development that we had. They built over 2,000 of these. And they carried troops used as a commercial transport in the Taiga and into Siberia, and quite a reliable machine. 4-bladed rotor. They said you got to have more blades nowadays. We don't want to increase the diameter, but more blades, and that's the way to go. We finally did that too. And there's the 4-blade equivalent of that Mi-8 or Mi-14. That's the H-34, and that was an aircraft that competed with the tandem rotor, which got an inroad with different people in the Army at Wright-Patterson. And they wanted to buy the tandem because they said it eliminated the CG problems, which we had and all, but we said we've eliminated that. We've got offset flapping hinges, and that takes care of the CG problem, but nobody would believe us in the Army. So when it came time when the H-21 was in trouble, this one didn't have that much trouble, luckily, and they competed side by side at Rucker and did 1,000 hours within 10 days of each other. But lucky we got the major part of the contract, so we built about 1,000 of them, and Rotorcraft built about 500. I'm only saying that gives Sikorsky a little credit here. I wonder why this is that way. It should be a pretty good slide. There's 2 of them in it? Okay. Maybe we just keep keep going. This is about the same machine. The other one was a commercial one. This is the Commonwealth 32, a very short machine, about 20,000 gross, with coax rotors. And this is the way I came to feel that helicopters should be built, because it's a much shorter machine, and if you put thrust in this machine too, like we did in some test projects, you get a pretty good performing machine, 130 knots at 40, and very little vibration because one rotor balances the other even if they're unbalanced. And the machine did pretty good. It was used on shipboard and many other places. And we came to the single rotor type in the same era, and this is a gunship called the Mi-24. And I won't dwell with it, but it's 5 blades and a fairly comfortable machine at 130 knots, and at 160 knots, it shakes like hell, but that's where they flew it most of the time. Just a parallel machine that we built in this country was the SH-3, and this is a development from the H-34, which you saw, and it developed into that when the T-58 turbines got built. We have no turbines in this country, that's why we were in the same boat with the Russians. We had to wait for turbines, and this was the first development of that. And the seaplane hull was put on by Michael Glorath, a Russian, worked for Sikorsky, and he thought that was a wonderful thing. Whether it was useful, I don't know, but we didn't do a heck of a lot of water landings or a heck of a lot of operation on the water, but it was nice to have a boat underneath you if you're over the sea. Navy thought so. 5 blades, that made that aircraft somewhat smoother. How am I doing on time? I'm going to speed up.
Well, you got about 3 or 4 more minutes.
Okay. Glad you told me, because I was going to take about another hour and a half. This is the Mill 14, 14 passenger machine, 5 blades, and 2,000 horse engines. Very excellent machine, thousands were built. This is the gunship. This is the Jolly Green Giant, which did so well in Vietnam, and rescue at sea over water with the drogue to be able to refuel from C-130s. Then this is the Russian Navy machine, the Mi-17, and this is a big machine. Inside they could carry 20 people, they carried radar, and they also could tow sleds for detonating mines. Then I just thought I'd put just a one-line pitch in there. This is the Mill 12, 250,000 pounds gross. That's 250,000 pounds. And that's what they always said when I was over there. You got to build them bigger than the U.S. Everything, no matter what. And this, they built 6. They tried to get this back from the Paris Air Show, and it had a heck of a time. Got to Poland, began to vibrate and be unsynchronized on the rotors, and that was the end of it. The CH-53, which was first built by Sikorsky way back, was developed into the CH-53E, which is a 3-engine machine for the Navy at 20,000 horsepower, and this is an increased rotor diameter. And we never could build a new rotor when we built a new helicopter. We had to take an old one and modify it to work. So we put 8-foot steel extensions on the blades and increased the rotor diameter, and that's why this aircraft is now in service. They've built about 20 a year. This is the Mi-24 gunship. I just put that in there to show it quickly. What the heck's her name? Titania Rostogorova, and I can't remember the other girl's name, flew this aircraft. These are the gun camera pictures of the world record, 228 miles an hour. The Russians were unhappy that girls had to do it. They thought that men ought to do fast things, important things. And this is the Mi-28, which is the new one. It lost against the Commonwealth 50, the coax gunship, but evidently politically this one came into power again. I've just got a few, Dick thinks I'm close to the end, and I probably am, but I've got a few slides at the end that you've got to see because they wind it up on a different note. The tail rotors here are two tail rotors, put at 30-degree included angle, and they didn't require a new tail rotor development. This is Feinberg of the Mill Bureau now, and Mata Tishenko used to be the head of the Mill Bureau. He's now a technician and academician. He teaches.
He's here today.
Where? Okay, well, we haven't got time for amenities. This one I thought you'd like to see. They were doing some tests to decide whether you could blow the blaze off a rotor if the rotor gets combat damage and gun damage in flight. And this fellow flew it, and they blasted the rotor off, and he survived with no problem, he said. He said, but he was alive when he said that. This is the Mi-26, which is a 117,000-pound machine. It's about 30 feet high, and you can stand up on the top where the engine inlets are, and the engine inlet is about 6 feet in diameter. It's a real aircraft, 23,000 horsepower. I'm going fast because I gotta end it. This is the R6 at the volcano. And then this is a machine to drop, to tow any minesweeping equipment. There's your author here, your guy that's talking in the Mill 4 in Russia in 1959. This is one I proposed. This is the, you wanted to give us about 3 or 4 minutes or whatever on the future. This is what I propose for the future. I still do. We got to get costs down and all. That fuselage is pure dual hardness armor, nothing else. There's no structure or anything in it. And it's got a PT6 engine and coax ABC type rotors. And we had some pretty good performance for it, but nobody wanted to listen. This one I just put in there because that tail cone is again paper, composite paper, and it survived the testing. Fiberglass cabin technology, all this other stuff is either magnesium or fiber or composite. This is a 8-pound composite gear for 3,000-pound load for that helicopter. We're going to get to the end of this instantly. I'm sorry, but I'm a trial guy, and you've got to give me a little leeway. This is a 250,000-pound machine for a 60-ton payload to carry missiles. And this is the way it looked like we could provide a propulsion system. One big gearbox, 4 big turbines, and those big exit wheels for driving the low-speed shaft into the gearbox. And as you can see there, it's 71,000 horsepower. But it looked practical. This is a 60-ton machine that Igor Sikorsky thought would be very nice. Rigid rotors and about 25% empty weight to payload. This is the ABC, which I feel is the next generation of helicopter, because you can put thrust on it easily. You don't have to tilt the machine at all, and it's a lot simpler, basically. And the reason it's simpler is because I don't have to prove it at this particular time. And you see there, maximum speed that we talk about, 300 knots. And hover ceiling, 4,095, but rotor diameter is 48 feet for a gross weight of 11,500. And we won't go into this, but this is the efficiency of the ABC rotor, the rigid rotor, versus the flapping rotor. This is going to be a squad carrier, completely all armor again. Yeah, just one more. This is an important slide for the Helicopter Society. President Eisenhower came to the Society as my guest in 1959 when I was president the second time, and this is what he said. Looks like my aide blew it again. We were giving him information that probably wasn't exactly what he thought should be given. But that's it, and we thank you very much for your attention and for allowing me to proceed on with my slides. I really had 11 hours of slides. And I've got them with me here. They're not in that slide projector. And the only one thing I'd say for the future, we've got to get the cost down. We've got to get the helicopters quiet. I've been saying that for 20 years. And just lately, we've had some feeling that it might happen. And it can happen. We need more blades. We need tip speeds way down. And we need engine silence and take the penalty. But again, it's got to be done by economics. And that's a tough one to overcome. Other than that, thank you very much. I have many more minutes of this type of presentation on the future. If you'd like to talk about it somewhere in the hallways here, I'll be glad to be there. Or
He
5 different designs. A single rotor tail rotor, a coaxial, a side-by-side. I think you have a 3-rotor helicopter, and a tandem. And we designed all to the equal knowledge of each of those systems. And the tandem would always come out best. And we said, why not? And so we struck out on the tandem. you're selling time, you must have a machine that will get from A to B in the shortest time. And therefore, speed becomes a necessity after you leave the functions that have developed up to now as log lifting, firefighting, rescue. All of those things are fine, but they needed hovering. That's why the Canon was so good, because it could hover better than anybody else. Got it?
Yes, sir.
So, but now we've finished with those projects. We finished with those objectives. Now the objective is that it's more of a transport. And as a transport, speed becomes a very basic thing. Now, of course, reliability, day, night, all weather, etc., all those things are very important to have. But the biggest thing of all of these things is that when you go into commercial work is the fact of safety. Now, safety, we've been telling everybody that, gee, you know, this machine can fly without power. You can auto-rotate and glide down in safe landing. Try it. There's a lot of fellows in this room that have tried it and didn't have such a safe landing. Now, it's true that we can, under ideal conditions, auto-rotate, flare properly, and come to a landing, but it's in the modern helicopter with the high disc loadings, that's not very easy to do. So we then said, oh, well, we'll put another engine on. That'll give us higher reliability and higher safety. But only enough to take us at the period of minimum power, speeds between, say, 40 knots and 60 knots in that little bucket. But we won't put any more power in because that would be wasteful. Well, today we are faced with ICAO's decision and the European decision that they believe that a transport machine should be able to hover in any position and any condition of its flight with one engine out. And that is something that I think is fundamental to the safety of vertical lift transportation. When it comes to size, the Russians have shown us, and Marat has just come into the room, who has built the world's largest helicopter. And it's a great, great thing. And they have a lot of uses for that type of cargo lifting in Russia. But here, if we're talking about transport machines and talking about passengers, we don't have anything that's that large, commercially speaking. And therefore, we have to think in terms of what is the size that's most economical to the mission of transport that we're facing. So size becomes important. As a guess, it appears that 50 passengers is about the right size. Maybe that's too big, maybe that's too small, but that's about where the Convair may start for the airlines. Now, another thing that bothers us very much in our business, everybody says, oh my gosh, it vibrates so much. Well, that's a problem too that has to be faced. Another thing that's said is it's so noisy inside the cabin. Well, that's a thing we have to fix. People outside say that it's noisy, but I don't know what you do about that. That's probably the best thing is what Alex alluded to, and that is lower tip speed. But last and not least, all of this must be done on the basis of what the military is now calling affordability. That means cost. That means how cheap can you make it? How little can
chairman's suggestion that I talk a little about the early days of helicopter development in this country, using the Miller aircraft in the 1940s as kind of a launching spot. I'd like to take a little different tack than with the predecessors, august group here at this head table, and look at the industry through the perspective of the corporate side. And then some of the actions that I think are necessary if this industry is to survive and prevail and grow. It's been a number of decades, really, since I've been out of the aviation business, I guess 30 years, and other than my position as a member of the board of directors of the Boeing Company, where I've been almost 20 years now, I haven't had any direct association with it. All of these other companies, 27 that we've had over the years, some the largest in their industry, some modestly sized, but the fortunes have been successful. It's kept me from really thinking about helicopters and aviation of the future. But and certainly the material, in answer to Dick's request, it kind of reminded me of those heady days when this damned industry got going, and it was a damned industry because it was a damn lot of fun to be part of it and a privilege to be part of it. It reminds me of the old saying, it's like wine, women, and song. And you look at it in the perspective of 50 years later, it's more like Metrical, same old gal, and sing along with Mitch. Now, if anybody says, who's Mitch? They're too young to be in this group. In any event, it's a privilege to participate in the birth of a new industry. You don't get a chance to do that very often in your life. You all have, and you know what I mean. Picture, if you will, that there were 4 companies in the 1940s that actually reduced to practice what had generally been invented in Europe. And Skorsky, of course, and Frank Biasecki, a wonderful contributor. Art Young, incidentally, I had lunch with Art last week. He's doing well at 88, 89 now. He's in good health. 88.8. Well, he seems like a kid of 60, I'll tell you. He hasn't changed a bit. But then we had Art Young who was Bell, who really started the helicopter industry for Bell, and Rotorcraft. Those are the people that got into quantity production in the 60s, and shortly thereafter, of course, the great Charlie Command came along to leave his indelible stamp during the early 50s. Now, again, think of the industry as pretty much centered in the East Coast. There were several forums held where everyone had a chance to interrelate to each other, to bring together knowledge of Plage and Frank, and of course Skorsky and many others, but Art Young included. But it was a chance to really get a feeling for solutions to problems. And the Ottajaro companies, of course, that were clustered in Pennsylvania, provided an excellent conduit to transcribe the information of the technology, the successful technology of Europe into then a small body of people located in Pennsylvania and Connecticut. Our little company, Hiller Aircraft, was isolated from all this. It's 2,400 miles away. And how we built a corporation and how we developed products, therefore, was looking at this problem totally differently. None of us in the West had ever seen a helicopter fly. We had not been exposed to the European knowledge of vertical lift, which had been brought, as I say, through the Ottajaro companies to Pennsylvania and Connecticut. We knew nothing about control, that sort of thing. We're a bunch of kids. But I had a shipyard welder, a naval architect, and an old craftsman who could machine anything, and myself. Said we did things differently. Look at how the production then evolved by the number of aircraft that were tested. Igor had one aircraft with a lot of iterations to it. Frank had a nifty, a little aircraft, which only a few of you saw fly. I happened to later see it in all its greatness. But it was the launch pad from one machine into receiving the government-sponsored development of a larger, great tandem rotor helicopter fleet that was produced. And Bell had a rudimentary platform, and two more refined machines, but basically the same kind of technology and same conformation. We had to start from scratch, and our learning cycle was much longer. Compared to the onesie-twosies before the launch into the production, we built and flew 9 different configurations of aircraft, and we learned with each one. And the other point is that you've seen all military aircraft up there except the onesies and twosies. From an economic side, and unlike the other companies, we achieved quantity deliveries in production without any direct or indirect financing from the government. It was all a private venture. There is another impediment which hadn't been mentioned today that should be acknowledged, and that it was a very hostile environment for us in 1940, 41, 45, and 6 into the war. The helicopter, it took a congressional investigation, the Truman Committee, to get the Navy off the dime. They were against rotary-wing aircraft for a number of reasons. The senior administration in the Army, who had agreed to, with the 1957 Key West Agreement to split up the armed forces, was not aviation oriented, and looked at the helicopters in proportion. The Air Force had its head in the clouds with its new mission statement as of 1957 of heavy bombers and fast fighters, and were looking for sleek, powerful, fast machines. And they therefore had little interest in these ungainly, shaking devices, noisy devices, which was the helicopter. This was the first experimental unit that we built in an old garage in Oakland, California. Engineering on it was started in 1941. The company was formed in 1942. And by the end of 1943, we had constructed this coax. And don't ask me why we chose coax. I really don't recall. But we wanted to be different. And that was one major reason. It was unique. It had the world's first successful all-metal rotors. It was the first successful rigid rotor helicopter. And in this very Edisonian kind of facility, it grew for 2 years until the fall of 1973, when we were ready to run it up. Now, once again, none of us had ever seen a helicopter before. And so we thought, heck, if we could build it, we could fly it. No problem. Here I am, for instance, running the machine up, trying to get the engine cooled, and Frank would tell you we both had the same trouble. It took months and months to really get these damn things to cool. When we finished the test, the aircraft's tied down there. I thought, I'll just pull that pitch up a little and see what happens. And when I did, there was a tremendous explosion.
was the harbinger of what was to come on the first flight. I have been through 3 major accidents, lived to tell it. One thing is common in accident. I don't know if you've ever been flying an airplane and had a complete airplane disintegrate around you and not hear a sound. And as I've talked to many people along the way, 90% of them said, you know, I never thought of it. There isn't a sound if you're trying to save an aircraft from crashing. But we repaired it. The rotors were very robust, and I'm going to take you quickly now through a series of slides just to show what, starting there, this little company did and was interested in. We finally got our act together at the University of California Stadium in the spring of 1944, 50 years ago, and flew then the first rigid-rotored coax, United States rigid-rotor helicopter in the world, and the first all-metal rotors. It was a good test stand. We could increase or decrease the size between the rotors, the length of the rotors, the fully rigid rotors to semi-rigid rotors. Here I'm coming into land in my future wife's backyard in the country, and my future father-in-law, and we thought this would be a great stunt to get their attention for their future son-in-law. It worked. It worked. We've been married almost 50 years now. Rigid rotors were a very important objective in our life, and these are super rigid rotors. We built 3 of these machines. Little is known about them. We flew one of them. Our approach was, I'm sorry to say, Alex, 20 years before you. The aircraft was destined to have wings and a pusher prop. We tried with 4 blades, 6 blades, and 8 blades, 4 in each, and super rigidity. And I was terribly pleased to see 20 years later that somebody picked up a good idea. And I agree with you. It still is a good idea. This then was a 3 series of aircraft, all different, one without any covering and 2 with covering. We're still chasing that pot of gold at the end of the runway is good. For commercial business, which is a fallacy, of course. And then we turned to what was to be our first production helicopter. This was designed in 1945, Frank, but flown in 1946. The first successful use of the NOTAR came along 35 minutes later. And in fact, this was to be our first production machine. A beautiful 2-place. We were in the process of building this in 1945-46 to be the first production helicopter. Side-by-side seating, 165 horsepower, all metal, with a jet of air out the back of it. We have that aircraft now put away in our museum in California. As to single rotors, we built several. This is one of them with a gyro-type head where you really point it in the direction you want to go. It was totally unstable. And a couple of seconds after I took this picture, Frank, our chief test pilot by that time, had rolled it up on the ground. And we spent 24 hours trying to say, how are we going to have a totally stable helicopter? And out of a few minutes discussion came these aerodynamic paddles, which became the kind of trademark of almost 3,000 aircraft which we produced over the period we were in business. And that was the little aerodynamic control surfaces. You could, on a windless day, you could load the shot bags into the seat, and that little machine would hover continuously. If the ground had a flat spot, it would go to that flat spot, and then it would come back the other way. But it was absolutely stable. And out of that then came the production version, 3-place, all-metal construction, first helicopter to be all-metal construction. Inherently stable longitudinally as approved by FAA. We had the 3rd FAA approval in the United States of helicopters. That went into production after 9 different types of helicopters were developed because we were feeling our way along with no exposure to what the industry had done decades before. The plant coast to coast, first helicopter to fly from coast to coast. About that time, 1949, 1950, the French government came and said, we're fighting a war in French Indochina. And we need a light helicopter to make air rescues, air evacuation. And they took these two and another 8 or 10 or 12 followed later. And among other places, after several years, it fought in the Battle of Dien Bien Phu, the closeout of the French domination of that part of the world, with numerous evacuations. It's said by the French to be the first use, the routine use of helicopters in air evacuation. And that was a little privately financed helicopter that did it. One of the great pilots, and many of you know her, Jane, you know her well, is Madame Valerie Andre. She's a neurosurgeon who became the first, maybe only, general in the French army. And she and her friends undertook hundreds and hundreds of rescues in these small machines. The start then of the air evacuation use of helicopters. The Army finally got its act together, and well, a couple of them, that was our first military business, after we had produced substantially for the commercial markets. And ordered these two, and then 100, 200, 300, 500, and so on. And they were used in Korea. The Army loaded about 150 pounds worth of gear, electronics gear, and homing device antenna on top of it. They didn't perform well. They were a light civilian machine, overloaded. But many rescues were undertaken. The H-23B came out of that bigger engine. The Navy version, with the quad gear, and many of these were bought by the British Royal Navy. Civilian version was sold in quantities. The C came along, the D came along. We were talking to Dick earlier. This was, the Army gave us a contract to produce a 1,000-hour between overhauls transmission and drive system. And this was the first helicopter to be approved by the Army for overhauls starting at 1,000 hours. At one base alone in Texas, there were 600 of these machines, all ours, the largest concentration of helicopters ever. They put on about 3 million plus flight hours in their period of operation down there. We went on further on private funds to build the high performance. That machine with blower holds the altitude record of almost 28,000 feet still. And it was produced by other people until a year ago, which made it the longest running production helicopter in aviation. This was an L, notice no paddles. What were we doing? We were taking a kind of an erector set concept approach to having a helicopter that was a good one-place, two-place machine, and all the way up to a six-place machine by changing bodies and rotors and basically the same pieces were doing. Here's a five-place version with a PT-6 in it. Here's a six-place. Still have this aircraft put away. Excellent little machine, but again, funds were limited for us, so we couldn't pull all of these things into production. Let's look at just some of the fundamental projects that we had underway as example only, and there probably were 150 of them. Here's 5 or 6. Frank was having trouble with his H-25 vibrating everybody's upper little fillings out, and with the H-21 also. So the Air Force came to us and wanted us to develop some kind of a tip damper, a sympathetic tip on the rotor to iron out its oscillation. The area of tip engine development, we built steam-powered rotors. We built the world's first successful hot cycle rotor, cold cycle rotors, rockets on the tip of the rotors, pulse jets, ramjets, and the turbine on the tip of the rotor. And this was the start. This was taken, one of 3 ships, but taken up at 7,000 feet above Lake Tahoe for high altitude runs. Nobody with tip engines had ever tried to really apply them to use. Sure, McDonald and a couple of others flew them, but no one tried to apply them to real application. There are 3 of these little Hornets, wonderful little machine to fly. Here is a hydrogen peroxide tip power unit for takeoff and as an autogyro, 125 horsepower Lycoming for forward flight, as another one of the tip jet works. Well, by this time, we began to receive funding. All the other was on private funds for this very wide use of tip engines. Because of the tip engines, Jim Gavin, who was heading R&D at the time, came to us and said, can you produce for me an experimental machine that had wire-guided rockets and recoilless rifles and regular rockets. I think he had 8 or 12 of them that had to be on it. So we built this thing at a very high priority, and he was using it so the ground-bound generals would knock it down. This then became the first usable armed helicopter. We had received the first contract ever from the Detroit Arsenal earlier to study armed helicopters, and this was just a follow-up. We also built out of contracts a bigger tip-powered, ramjet-powered, I think 25 machines were built for the Army and the Navy. This is the Navy version. There was a pretty hard-fought competition for a retractable, stowable rotor, full size. We won that because of the tip power, and while it never went anywhere, maybe because it was just for the Air Force, I don't know. It was an interesting problem, and finally, on the tip power side, putting actual turbines on the tip of the rotor. We had 2 families. One was the initial one, which was a Williams engine just thrown on the rotor, and the other was a very advanced engine, which was subjected to many hundreds of Gs. Dick, do you remember what it was? 1,100 Gs. And based on this, we went into a competition to build the world's largest helicopter, and we won it. And on a 3-step program this is with Continental Engines, I believe, located on the blade tips, 2 to a blade. And sure enough, just as they screwed up the Frank's 16, they said they didn't have much requirement for heavy lift, and they did the same thing on this, and they did the same thing on the Boeing VTOL variant that came with it. Ducted fans, we spent many years. The first stand-on platform we worked with was in 1947. This happened to be the world's first VTOL ducted fan man-carrying aircraft. Neat little toy. There's Bill Johnson, the pilot, simulating a hand gun being fired. Out of that, the Army wanted a bigger one with 3 engines, so if one engine stopped, you could still fly. But it was too heavy, the man's weight wouldn't control it. But we got another contract, which was interesting. It was a coleopter that actually flew in its rudimentary form. Here's the prototype. It never was finished with the ring and rest of the airfoil put on there purely because the Army decided they didn't they weren't in the high-speed reconnaissance game. This was another project to try and make the D-58 supersonic bomber of the Air Force take off vertically by taking the thrust of the engines and through augmentation, pushing them down. These weren't paper studies. These are hardware pieces. That's the little round thing you saw in that previous slide on the wing, little round holes. This was the full-scale hardware that was tested in multiple augmentation lift devices. We received many, many contracts. All had hardware connected with them. The first transport-sized aircraft and the first tilt-wing transport contract was awarded Miller Aircraft in the early 50s. We had design studies from the Army, the Navy, and the Air Force convertible airliner. The Air Force X-18, we used the nose and the tail, just the cockpit and the aft section. Of the Chase, we used the lifting props and engines out of the Pogo program. But it worked. We were able to get it up 9 flights, about 18, something like that, down in Muroc. And while it never hovered, it got through the critical area. And out of this, we submitted a proposal for a larger machine. Let's see, with 4 GE 58s, I believe they were. And that turned into a competition. So we scurried around and got bought, and Ryan with us, and we won that competition for the XC-142. We had all the movable surfaces, but more important in Caterpillar, we had all the guts of the airplane. This is in Palo Alto, California, off the field where we built, at that time, the largest, highest powered test stand in the VTOL industry. From the sublime to the ridiculous, we won a contract to build a few of these little air-droppable, collapsible helicopters for the Marine Corps. The mission was to be dropped in the tip tank of a fighter down to a downed pilot. He had to assemble it in a few minutes. Actually, the spec was for 4.5 minutes without any tools. And then the theory was he'd fly it to an open area, or he'd fly it to a river, and an SA-16A Grumman would come in and bring it back alive. We developed another similar one, only this is 6-place turbine-powered, never sold it, which could be dropped from a C-130 and put together in a relatively few minutes without any equipment. We had such things as downwash studies, back to basics, back to understanding what was going to be practically required as you went up in disc loadings. A number of programs. We had a flying submarine for the Navy, which resulted, never built it, but resulted in about 6 years development of an engine, a jet engine, that could be submerged in water and instantly then started up. And finally, the world's largest aircraft. This was a study we did for NASA, and Warner von Braun Hoystein later came with us as head of our engineering for a 400-foot diameter rotor, which was an air tug, tip engines, which would catch a spent 400,000-pound booster rocket and bring it back to Canaveral from where they air caught it down over the Bahamas. Great idea, but that's another story. Now, Dick, I have just about 3 minutes. Looking at the future, as I said, I've been out of this game for a long time now. But let me tell you that having resuscitated almost 30 companies now, there's a pattern that comes of an industry's growth. It's divided into three eras. It's almost like a human body. It starts with adolescence, it goes into maturity, and then it starts down the hill in retirement or senility. I don't know which it is, but we concentrate in rebuilding companies in trouble, and they're companies that are in the multi-billion size. We got a hold of Hughes Tool Company, was one of ours. Baker, York International, all big companies in their field, but all suffering from the fact that they were not able to survive in the environment of a mature industry. And what we see are that the people who are so good at building in the initial phase, in the startup phase of a new industry or a new market, doesn't make any difference, material, product, or service, do not necessarily go at the maturity, management-wise now, go at the maturity section of the birth and the maturity and then the death. Now, it's a period of increased competition, that's maturity. reduce your costs, your direct costs, between 5 and 15% per year just to stand still. It's a totally different way of looking at things. Management must learn to do things differently. Now, we're all in the business of making a fair return for the stockholders. You and I are money managers, no matter what you do. And what we're charged with is working other people's money. And we have to learn to do it in the most effective way. Some people are going to be able to do that in this industry, and some are not. Maturity means that it's time to rethink the next generation of market, the next generation of product, which better suits the ever-changing demands of a mature market. If this industry doesn't, you're going to see competition continuing to force prices down, and margins erode, and therefore money to flow back into new products soon disappear. As a founding member of this society, I'm leaving with one rather basic thought, that having seen the helicopter evolve as it did over 50 years, it appears to me that the present concepts are reaching its zenith. With government funding going down in a mature industry, a great opportunity, though, does exist for those willing and able to make the transition and recognize that the future holds a different business environment than what we have seen in years gone by. Those are lots of words, but I mean, there are great changes ahead of you. And I would hope that the industry got its act together and was able to meet the challenge. Because those that do are going to succeed. Really appreciate being here, and thanks very much.
The last speaker is Mr. Charles Mann. After graduation from Catholic University, he worked for Hamilton Standard and very rapidly became chief of aerodynamics for their helicopter activities. While he was there, he founded his command aircraft laboratory, primarily to pursue some of his own helicopter activities. He left Hamilton Standard in 1945 and founded Command Aircraft Corporation. His first successful helicopter, I believe, correct me if I'm wrong on this, was the K-125, which you see in this photograph, which he piloted. And it must have been in the winter. This was followed by the HOK, the HH-43, and the UH-2 production helicopters, and a number of additional experimental projects. He later expanded his interests beyond the aerospace business and formed companies producing nuclear products, musical instruments, electromagnetic propulsion systems, and power transmission components. And in the late 1960s, he formed Command Aerospace Corporation, which brought some of these companies under a corporate umbrella. Charlie Command is still today a very, very active president and CEO of Command Aerospace.
Thank you very much. I've never been lined up that before. This is going to be fun. A few observations. It really is, indeed it is, a privilege to live in a place like America, where I could start a company with a $2,000 investment start things and be a part of a growing industry, a founding industry. And usually that's a blessing that comes to very few people. I'm on a big high these days, and I'll share it with you because I feel I'm on the second cycle. And that doesn't very often come. And I couldn't have had a more professional introduction to what I'm going to show you than what Stan Hiller just did for me. So thanks very much. We have been an industry that predominated in the ingenuity and creativity and all of this and trying ideas go on. We too built convert planes, we built jet helicopters, we flew the world's first non-piloted helicopter. All the companies had to survive through their radical ingenuity to try things and all of this. But we had a customer that was generally financing most of that radical development, the military in various of their forms. As Stan has aptly pointed out, these have gone through transition. We saw this coming back in the 50s, and in the 60s, the original advice of John Pride when he gave us our first contract, Admiral Pride, came to fruition, which was diversify. So we have now a multiplicity of companies, but our command corporation, got to correct you on that, I'm not president anymore, I'm chairman. Command Corporation is in 3 industries. They are in consumer products, they are in industrial products, and they are in high technology products, of which our aerospace company is a piece, one of 9 companies in very high tech stuff. However, for me, the old aerodynamicist, playing around with the helicopter has been an awful lot of fun. And I've gone back to it and had fun, almost in retirement, but not in retirement, because I'm working about 70 hours a week, bringing forth a machine that's called a K-Max, and you're going to see it in just a minute. But I'm going to tell you why it's here. We've essentially followed in the industry the bid and preference of our military markets. So they have had a very significant part in what has been the development. Configuration, purposes, all the rest. Everyone in the industry has applied that technology sort of off the side to commercial application. And the commercial market that evolved has been essentially people movers. Sure, we have Columbia and Ericsson that are doing high lift work out there, but it's not an industry. It's been a specialized application thus far. 3 years ago, I was attracted to the field of logging as a kicker by the people that were flying our old discarded H-43Bs. And we went out and surveyed the market. And behold, we found a very surprising thing. Here we were all using helicopters designed essentially to carry people, some exception, to try to do commercial jobs. But nobody had designed a helicopter in this day and age for doing specialized things like vertical lift. And that's when the idea began to occur to me, my God. And I'll bury it here and tell you a story when I was a kid. Right here in Washington, D.C., where I grew up, my father was with Bernizer Company, and I remember out on Rittenhouse Street on a Sunday, going out to see some of the work they were doing, grading, and the dirt was being moved in wagons drawn by mules and horses. That happened in my lifetime, right here on Rittenhouse Street in Washington, D.C. Now then, I also remember when we lived on Buchanan Street, the first station wagon. It was a little Ford Model T with some wood sides on it for surveyors to take their equipment out. That was the first station wagon. Well, my God, what's happened? aerodynamic if you give up some of the fantasies of the military. If you take all that we've learned, we can make a machine very cheap. Thank you. We are doing it. We can make a machine that can last for countless hours with no fatigue failures, Mark. We know how to do it now. It won't fly really fast, but it can lift. So I brought along our K-Max promotional film. I apologize because it is a promotional film. But in it you will see the span of this essential 50 years because it shows the first K-125